Hi there, welcome to Raelene Maths. In this video we will write the equation of a line in two different examples. The first asks us to write the equation of the line that passes through the points 3, 0 on the x-axis and 0, 2 on the y-axis. I recommend always graphing the line or sketching a diagram at the start of any problem. We can use the general form for the equation of a line, which is the point-slope form, y minus k equals m times x minus h. We could use anything instead of h and k. We could use a and b, x1, y1, anything that represents a point on the line. So h and k are going to represent the coordinates of any point on the line. We also know that m represents the slope or the gradient, and it's given by the formula delta y over delta x, which is y2 minus y1 over x2 minus x1. I will designate the first point, 3, 0, as x1, y1, and the second point as x2, y2. So first I will calculate the gradient using that formula. So y2 of 2 minus y1 of 0 divided by x2 of 0 minus x1 of 3 gives a gradient of negative 2/3. This is the same as a gradient of positive 2 over negative 3. In the first case, negative 2 over 3 tells us to go down 2 spaces and right 3 spaces from one point on the line to get another. We could also reverse that by going 2 spaces up and 3 spaces to the left from any one point to get another on the line. That's what the second version of the gradient tells us. So I'm going to use the gradient as negative 2 over 3, and now I'm going to substitute my gradient and the coordinates of any known point into the form of the equation for the point-slope form. So I'm going to use h, k as my first point, and when I do that, I get y minus 0 is equal to the gradient of negative 2/3 times x minus 3. The 0 here can be disregarded, so we get y equals negative 2/3 times x minus 3, and I'm going to distribute that negative 2/3 throughout the brackets, which gives me a simpler equation of y equals negative 2 over 3x. Negative times negative is positive, and 2/3 times 3, or 2/3 of 3, is 2. This is a special case form where we have the gradient m times x plus c, where c is the y-intercept. The y-intercept is the specific point when the x-coordinate is 0, and we see that we have the y-intercept as the x2, y2 ordered pair. Because we have the point on the y-axis, we know that c is equal to 2 directly. So we could have immediately used y equals mx plus c, which is a special case of the general equation of the line. It's a special case because it's specifically when we have a point that is on the y-axis. When that's the case, we can substitute in the value for m, and we can substitute in the value for c. If we do that, having calculated the slope, we would get y equals negative 2/3 x, and then plus the value for c, which is given by 2. Either way works, but the one-size-fits-all approach is the general equation, which is this point-slope form. In the next example, we are asked to write the equation of a line that's parallel to one line and passes through a given point. So because we have a point given, all we need now is to find the slope of our line, and we can use the point-slope form to write its equation. In order to get the slope, we generally have 2 points, which we don't have. Instead, we are told that our line is parallel to another line. Parallel lines have the same slope, so we're going to use this fact to rearrange the first equation into the y equals mx plus c form to get its slope, which will be the same as the slope for our line. So to rearrange for y equals mx plus c, we must isolate y, which means we must undo what's being done to it. We really have 3y plus 4x equal to 12, and so we see that we have to subtract 4x from both sides. When we do that, we get the rearranged version that 3y is equal to negative 4x plus 12. Then we divide both sides of the equation by 3. When we divide the right-hand side of the equation, because there are 2 terms, each term gets divided by 3. And when we simplify, we see that y is equal to negative 4 over 3 times x plus 4. From here we can see that the gradient of the line is the coefficient of the x, and therefore the gradient is negative 4 over 3. It's a good idea to sketch that line. We see that we've got a y-intercept at 0, 4, and we go down 4 spaces and right 3 spaces to get a second point on that line. So sketching that line gives us a guide or a benchmark for our line. Now we know that our line has a gradient that's the same, -4/3, and passes through a point which we will call h, k, whose coordinates are given by -2, 4. We can plot that point, -2, 4. We can go down 4 and write 3 spaces, and we can sketch that line as well. And then we can put this into the point-slope form of the equation of a line to write the blue line equation. When we do, we get y minus the y-coordinate of k, or 4, equals the gradient of -4/3 times x minus the x-coordinate of -2. And minus and negative gives plus. We can leave the equation in this form. Sometimes it's expected or required that we rearrange to give y equals mx plus c form. When we do this, we are going to expand the right side and then add 4 to the end. So we're going to get y equals -4/3 times x, multiply -4/3 times +2 gives us -8/3, and then we add 4 to both sides. The last thing we need to do is to get a common denominator for these two fractions. So this 4 becomes 4/1, which we multiply by 1 in the form of 3/3 to get a common denominator. And then we get -8/3 plus 12/3, which gives us a total of +4/3. So the equation of our line at the end in y equals mx plus c form is y equals -4/3x plus 4/3. It's a bit of a coincidence that we have the same fraction part for the slope as for the y-intercept. We can also confirm that the y-intercept of 4/3 seems reasonable because 4/3 is the same as 1 1/3, so it certainly looks like we have a little bit more than 1 for the y-intercept. There you have a couple of examples of writing the equation of a line given different scenarios. Keep in mind that the most general way to write the equation of a line is the point-slope form of the line, but in certain cases, if we have the y-intercept, we can directly go to the y equals mx plus c form of the line. Thanks for checking out Raelene Maths.